Hi, and welcome to another exciting coding video where we're coding with C Sharp and the Revit API. If you're just joining this channel and you're just learning to code for the first time, I would recommend looking at some of the playlists I have where I explain key concepts about C Sharp and also how to set up your coding environment for the first time. If you've been following along, welcome back. Today we're going to be learning how to collect and filter elements in Revit, and we will be building a command to do that. So let's get started. So if you've been following along so far, you should have a manifest file, a hello world command, and a Revit application. We're going to be creating another command today and running that. So let's start by creating a new class within our first Revit plugin assembly as usual. To do that, we will click on our first Revit plugin, right click, and say add new item, or if you're working on a Windows computer, Control Shift and A. From there, we're picking a class, and this is a good opportunity to name our class. So let's call it collector, because that's what we're trying to do today, is to collect a couple of elements and report them. Awesome. So now we have a new class and it's called collector. We're going to start implementing our iExternal command interface and some other cool things. But first, let's look at some of the concepts that we're going to be covering in the code today. All right, so let's learn about some classes. The first is the Revit application. This is literally the overall Revit application instance. It's not usually accessed when you're writing add-ins, even though you do have access to the command data, which you reference from the iExternal command interface. This is how you access the Revit application. And from here, you want to access the UI application first. This is the application that is currently being used by the user. So we always want to access it because we want our code to influence this application. Next, we want to access the UI document. The UI document is a document that's open inside the Revit user interface. It provides access to the document, which is where all of our elements are stored. So all the elements you create, whether that's walls, floors, windows, or doors, are stored inside the document, and the document is hosted inside the active UI document, which is in turn hosted inside the application. So you will always, in coding, first of all, access your application, and then access your active UI document, and then access your document. The document layer is where all of your Revit elements are hosted. So when you're trying to select Revit elements, this is the layer of the classes in Revit that you are trying to access. These are what I call the big four Revit classes because all of them host all of our Revit elements that we typically want to work on. The next thing we're going to look at today is the filtered element collector. And this works by how you would typically think about water, right? You would first collect it and then filter it and then use it. So you first would collect basically all of your elements in Revit using a filtered element collector, and then you would filter it using one of the many Revit filters. But for today, because we're just working with typical Revit elements, we're going to be filtering by category. And so we're using a category filter. And then to apply this filter to this collection, we need to use something called where passes. This where passes is a kind of filter application. There are many others, which we'll not be covering in this video, but this is the logic for how we are creating our filter to get through to our Revit elements. The next thing we will encounter for the first time today is transactions. Now, a transaction is usually a container for a set of operations that are going to modify the Revit model. So if you're creating something where you're not really modifying anything, you may or may not need a transaction. But in most cases, when you want to do some sort of activity from the API where you're modifying the Revit model, in this case, modifying means retrieving a set of elements, collecting some parameters, changing something. You always need to set a transaction because this is what controls how Revit reads your actions. The next thing that some people may be seeing for the first time today is the new keyword. I've talked about this before in the beginner series, but the new keyword will initialize an object for the first time in a code and allocate memory to it. So when you're initiating an object or a class for the first time within your code, you use the new keyword to initiate it. And also the toList method will convert any collection or sequence of elements into a list and apply all of the methods and properties that are available for lists. If you don't know what a list is at all, I've covered everything in my beginner series and I explain it in much simpler terms. So now that we have an idea of the key elements of our code, we know we're making a filter, we're going to apply that filter. We know that we need a transaction and we know that we will convert it to a list because what we want to do today is to collect a list of walls and count them using the C# Revit API. It does sound very simple, but imagine you're working on a project where there's a very large amount of walls, and without having to resort to doing a schedule, you just want to know how many walls are there. I mean, it could be a different category that's more sensible for you. Maybe how many windows are there or how many rooms are there. The same code applies and you can just run a command in seconds and have the count of what you're looking for. So now that we've done some theory and we understand a little bit of what we're going to code, let's head back into Visual Studio and just start coding. Okay, so back in Visual Studio, we've created our collector class, which will be hosting all our code for today. The first thing we want to do is to make it a public class. I covered the topic of public versus private in the beginner series. So if you're not sure what that is, please watch that series. And we want to implement explicitly the iExternal command interface. Also something I covered in the beginner series if you're not sure what that is. Great. So we want to go a step further by implementing all of the data types associated with the iExternal command. So to do that, you can right click or you can use one of the shortcuts, which is Control and full stop. So that's what I'm going to do. And then I want to implement the interface of the iExternal command explicitly and also bring in the Autodesk Revit database reference. Perfect. Now that I have everything I need, I'm going to remove the exception because right now I'm not dealing with exceptions, but I do want to return a result when the code has successfully run. So as usual, I will add a return result.succeeded, which will be the last thing in my code. The next thing I want to do is to start our class with a transaction because this time around we're accessing Revit Elements and the transaction is usually wrapped in square brackets. So we want to say transaction attribute by accessing that attribute. And you can see it's referencing the autodesk.revit.attributes namespace. And then in regular brackets, we're going to put the transaction mode. In this case, we want it to be manual, so we're going to pick manual. Awesome. Now we've set our transaction mode. We have our iExternal command. The next thing that we want to do is to start creating our collector. So inside of the iExternal command, I will press enter. And then the first thing I want to do is to create my filtered element collector. So I will say filtered element collector. And I will click one of the suggestions to accept it so that I don't have to continue typing. Great. So let's give it a name because this is a variable we're creating for the first time. If you're not sure how creating variables in C# works, I do explain this exact code that we're doing today in what I would call plain English in one of my videos. It's called Explaining C# for Revit in Plain English. I recommend watching that if this confuses you a bit because I do explain that in much simpler terms. The filtered element collector is a variable on its own. So you first initiate your variable in C#. So if you're used to coding in Python or any other language, you would just say name of variable equals what the variable is. But in C#, you have to first state the type. In this case, we're accessing one of Revit's types, which is a filtered element collector, and then we give it a name. So let's call this collector. Awesome. Because we are instantiating this collector for the first time in our code, we will assign the new keyword and filtered element collector again, because this is the actual variable we're creating now. And then we will assign to it the entire document. This needs to be the document that is hosting all of your Revit elements. So we're going to have to create that UI app, UI doc, and doc, like I explained. But for now, let's just call it doc because we know that's what we're going to be calling our document variable. So let's go back and create that. So if you remember in my explanation, the first thing we need to do is access the active application. So we would say UI application and call it app or UI app. And we would say command data. It's already suggesting for us what we need, and that's exactly what we need. So I'm going to say tab to accept. Perfect. Then we want to access the UI document. So UI document. Let's call this UI doc. And this will be app dot active UI document. Tap to accept that. Perfect. And then finally, our document. Call it doc. And it's already giving us what we need. So I'm just going to tab to accept everything. Perfect. And now our code doesn't have any errors anymore because we've created a document. So our collector is literally collecting every single element that we have in our active Revit document. And that's way too much. So now we want to create a filter that we will be applying to the collector. Awesome. So let's access an element category filter because that's the kind of filter we want today. We have other kinds of filters like element class filter, element design option filter, even element filter itself, but we're filtering by category for today. So let's go with element category filter. I'll double click to accept and I'll give it a name. I will call it filter. I can pick one of these options or I can type, but I think I always find it easier to just pick one of the options. So let's do that. Double click to accept. New keyword because it's been instantiated for the first time. Element category filter. And now we will apply the category that we're filtering for. So you can see it's already giving us options for all of the different categories that we have in Revit. And you can literally pick any one of these. You can even pick the category of point clouds if you want, or analytical openings if you want. But what we want for now is just walls. So let's start typing so that we don't have to actually scroll through all of this. So we will say build in category. Let's accept that first. And then dot notation to access all the other categories, OST underscore, because this is how the API actually groups categories. And let's type W for walls so that we just filter through all of the many categories we have and get straight to walls. There we go. That is the category for walls. So we click on that one. Awesome. So now we have our collector, we have our filter. Let's apply the filter to the collector so that it runs through everything in the document and returns only walls. We'll just make it a regular schmegular variable and call it walls. And we will say our collector, which is the filtered element collector. Now let's access one of its properties to apply the filter. We will say where passes. This is how we want to apply this filter. There is also where element is curve driven, where element is element type. There's so many ways to apply a filter, but we want to say where passes, which means wherever there is a wall, apply this filter. And we will apply filter. And The last thing we want to do is convert this to a list because we want to actually count the number of walls that we have in the project. So I'll add one more dot notation and make this a list by using the toList command. Always add brackets at the end. It's an empty list and it will cast basically all of the walls into this list. Great. The last thing we want to do is find some way to visualize this because all of these codes, they just run in the background. We need some kind of dialog box to actually see what we've done. So let's add a task dialog. We'll go to our good old friend, the task dialog dot show so that it shows up. And then we will follow the rules. We need one string for the title and one string to tell the dialog what to do. So the first string would be the title, which would be number of walls. And then a comma to separate them. And here we're going to use something called string formatting because we want to convert something that's a integer to a string, and we don't want to have to do a lot of coding to do that. So by simply using a $sign to wrap our string, we can literally just type whatever we want inside of curly brackets and it will return it as a string. So let's first with the words, number of walls in project are. So these are all strings. These are all strings. But now we want to add an integer, which is the number of the actual walls. To do that, we're going to access the .count property of the list of walls that we have here. Because if you remember with lists, you can have counts, you can have list length. If you don't know anything about lists or properties, you can watch a few videos about what kind of properties you can do with a list. They're quite enormous. But basically you can count a list or you can check the length of the list or you can add something or remove something. It's all very interesting, but I don't want this video to be too long. So let's just accept that what we want to access today is the walls.count method. And we will add our semicolon to just end our code. And that's it, guys. The code is ready. The last thing we want to do, as always, is to work on our manifest file. Because this is a new class, if we don't have it added to our manifest file, it won't actually run. So the first thing we want to do is to sort of stop too many things running. Let's comment out what we had before with our application so that it just stops running. So to do that in Visual Studio, you would say Control K and then Control C, and it will add this syntax to your XML and basically turn everything in between into a comment. If you don't want to do this, it's fine. It just means that all the code you have will run. I really don't want to have to sort of load once in Revit every single time these codes run. So I'm just going to comment it out. I'm going to copy this because it's a command section of the manifest file. And I'm going to comment out the other one as well, just because I don't want to deal with it. So Control K and Control C. That's perfect. Awesome. So now we have the command we actually want. It's still the same assembly, our first Revit plugin. Let's create a new GUID by going to Tools, Create GUID, copy, and paste. Get rid of all of the extra stuff because we only need the characters in between. Perfect. Make sure that the full class name is our collector class because that's the one we just created. And we can change this text as well to be walls collector. This is the text that will show up when we run the code in Revit. I'm still the same vendor, so I'm not going to change that. And we're just about ready to go. To run this, I'd recommend having some kind of sample file where you just have a couple of walls in your project. Could be one, could be two. We just want to test the code. I recommend creating your own file because sometimes there are issues with the default sample Revit files that you don't get when you create your own. So it's always good to just create your own. We click on Start as usual to start debugging. If you're completely new to debugging, please watch the beginner series. Okay, that's the last I'm going to mention about the beginner series. Basically, If you're new to coding, I have a bunch of videos that will help you, but these videos are for people that have sort of been following along. Let's just agree to leave it at that. So I press start, and now we wait. If you have warnings in Visual Studio, it's fine as long as it's not an error. A warning is usually just telling you that something is not really going the way it should. It doesn't mean your code won't run. It's just a warning. An error, however, would be an issue. So there is our walls collector command. So we're going to load once. Great. So let's launch our sample project and just test this out. So I will go to my add-ins because it's an add-in this time and not an application. I'll click on external tools. There is my walls collector. I click on it. Number of walls in project are 27. There's no way I have 27 elements because look at my model. I just have 4 walls and it's counting 27. I'll explain why. So in Revit, the element class is divided into the category, family, symbol, and instance. Now, when you apply a filter, it's not only filtering for the instances, which would be the actual walls in the project, it's also including the symbol, which in this case is known as the type. It's including the element type and counting each element type also as a wall, because that's just how the API reads elements. It's not just the ones you've modeled, it's also the types of the different walls in the project. So we need one more layer in our filter for it to work correctly. So we'll just head on back to Visual Studio and stop debugging. If for any reason your code didn't show up if you tried this, it could be that your collector is set to do not copy, in which case it's not really being copied to your debug folder. So I would change that to copy if newer. And it could also be that you didn't follow the steps of adding the collector to your manifest file. So I think that once you do that, it should run without any issues. So let's add an extra layer to our filter so that it actually works the way we want. Right now, we're just adding a filter of category of walls to our collector, and it's bringing up everything, including the types. So let's add an extra layer before converting it to a list where we say dot where element is not element type. We don't want element types at all. And we'll put the brackets to make sure that the syntax is correct. And perfect. Let's try that again, shall we? We load once again. We pick our sample project. We go into the add-ins tab because this time around it's a command, not an application. We look for the walls collector add-in. There we have it. Number of walls in projects are 4. That seems like a lot more accurate number than what we had before. So now our filter is working. We can go ahead and do even more exciting things to it. In the coming videos, we're going to be learning more about what we can do with elements in Revit. I hope you enjoyed this one. I hope it wasn't too complicated for you to understand. If it was, please watch my C# explained in plain English video because I do explain this exact code in very simple terms. Thank you for watching. I really do appreciate you coming here and taking the time to learn this. This is a very valuable skill that we pay off. And in the next video, I'm going to be actually showcasing someone who has built tools from scratch and published it in the Autodesk marketplace and has really gotten a lot of success from it. So I hope you'll stick around for that one. Please subscribe so that you're notified when it drops. Please tell your friends who like to learn to code about my channel. I think it really is a skill that we need in the 21st century. And it really also helps me a lot when people view my content and subscribe to the channel. Thank you so much. I'm really grateful that you are here and I hope to see you in the next one.